Good day, Sir Barnido and Masters. I am WendyLobido, and I will be reporting about the third forecasting model, the qualitative models. So if the two presented models mentioned a while ago, the time series and the causal models rely on quantitative data, qualitative models, on the other hand, attempt to incorporate judgmental or subjective factors into the forecasting model. Opinions by experts, individual experiences and judgments, and other subjective factors may be considered. Qualitative models are specifically useful when subjective factors are expected to be very important or when accurate quantitative data are difficult to obtain. Since our subject is quantitative, I will be just giving an overview of the qualitative forecasting techniques. So we have four different qualitative forecasting techniques. First is the Delphi method. So this iterative group process allows experts who may be located in different places to make forecasts. And we have three types of participants of the Delphi method. We have the decision makers. The decision-making group usually consists of 5 to 10 experts who will be making the actual forecast. We also have the staff personnel who will assist the decision makers by preparing, distributing, collecting, and summarizing a series of questionnaires and the survey results. And last, we have the respondents. The respondents are a group of people whose judgments are valued and are being sought. So this group provides input to the decision makers before the forecast is made. So in the Delphi method, when the results of the first questionnaire are obtained, the results are summarized and the questionnaire is modified. Both the summary of the results and the new questionnaire are then sent to the same respondents for a new round of responses. The respondents, upon seeing the results from the first questionnaire, may view things differently and may modify their original responses. The process is repeated with the hope that a consensus is reached. The next forecasting technique is the jury of executive opinion. This method takes the opinions of a small group of high-level managers, often in a combination with statistical models, and results in a group estimate of demand. A method of forecasting using a composite forecast prepared by a number of individual experts. The experts form their own opinions, initially from the data given, and revise their opinions according to the others' opinions. Finally, the individual's final opinions are combined. The third technique is the sales force composite. Each sales personnel estimates what sales will be in his or her region. These forecasts are reviewed to ensure that they are realistic and are then combined at the district and national levels to reach an overall forecast. So a method of forecasting future demand for a product by adding together what each member of the sales force expects to be able to sell in his or her territory. And the fourth technique is the consumer market survey. It solicits input from customers or potential consumers regarding their future purchasing plans. It can help not only in preparing a forecast, but also in improving product design and planning for new products. So consumer survey method of demand forecasting involves direct interview of the potential consumers. Consumers are simply contacted by the interviewer and asked how much they would be willing to purchase of a given product at a number of alternative product price levels. Let's now move to the scatter diagrams. So a scatter diagram is a two-dimensional representation of a set of data. The scatter diagram graphs pairs numerical data with one variable in each axis to look for a relationship between them. If the variables are correlated, the points will fall along the line or the curve. A scatter diagram for a series may be plotted on a two-dimensional graph with the horizontal axis representing the time period, and the variable to be forecast, such as sales, is placed on the vertical axis. So a scatter diagram helps obtain ideas about a relationship. So I will be presenting the sales forecast of three products of the Walker distributors. So in figure 5.2, the scatter diagram for sales of um, annual sales of television sets, radios, and the CD players for, for year 1 to 10. So we have this data, annual sales of the three products from year 1 to 10 of the TV sets, radios, and for the scatter diagrams, so using the scatter diagrams for sales in figure 5.2 on how to forecast given the 10-year sales data, one simple way to examine this historical data and perhaps to use them to establish a forecast is to draw a scatter diagram for each product. So this picture showing the relationship between sales of a product and time is useful in spotting trends or cycles. An exact mathematical model that describes the situation can then be developed if it appears reasonable to do so. So to make a scatter diagram, input the data first as the data source for the scatter chart. So we input the year 1 to 10 and the annual sales for the TV sets. Then we highlight the data source, we insert the chart and this graph will be generated. So for the first example, let's have the TV sets. In the x-axis is the annual sales of the TV sets, and while in the y-axis is the year or time. So you can edit the minimum and the maximum data for the x-axis. So we have the minimum of 50, maximum of 300 with a step value of 50. Okay. Given the data, sales appear to be constant over time. So from year 1 to 10, sales is 250 TV sets from year 1 to 10, constant at a rate of 250 TV sets per year. So, in forecasting the sales for year 11, based on the sales data for the past 10 years, year 11 will also be 250. So, no matter what equation we insert, no matter what year we insert in the equation, sales will not change. And as mentioned, a good estimate for year 11 is 250 television sets. Same with year 12. So another example is the annual sales of the radios. So next, same procedure with TV. We input the year and the annual sales for the radio. We insert the chart and we generate this graph. Then we can set the step value or interval 20. with the minimum of 280 and the maximum of 420. So we have the sales data of radios for years 1 to 10. As shown in the graph, sales appear to be increasing at a constant rate of 10 radios each year. So starting at year 1 with 300 up to year 10 with 390 radios. If we will extend back or left the vertical axis, we see that the sales would be 290 in year 0. Now we have the equation of 290 plus 10 is equal to 300 in year 1. So the graph describes the relationship between time and the sales. So with the available data, a reasonable estimate of radio sales for year 11 and 12 would be 400 and 410 respectively. And as for the last example, annual sales of the CD players, in sales graph, the trend line, this line is the trend line. The trend line may not be perfectly accurate due to variation each year. As you can see, the increasing rate or decrease rate is not constant. For the year 2, it decreased by 10. For the year 3, it increased by 10, and so on. However, sales appear to be increasing over the past 10 years. So if we had to forecast the future sales, we would probably pick a larger figure each year, the figure above the trend line. So in this case, the forecast for year 11 is 200 CD players. So I hope I was able to clearly illustrate on how to forecast through the scatter diagram. So that ends my report. Thank you. The next reporter will be Sir Arbel Losada. Thank you.